show you how you can use Desmos as part of your homework if you need to, and just consolidate your understanding. So the link that you click on Google Classroom is going to take you here. This is just a little thing I made for you guys to be able to play around with the numbers. So you can see when you're using Desmos, you can just type in, for example, f of x equals x squared. When you type that in, you get your graph. It's a nice simple x squared graph. What you can then do is just do f of x plus n. Now you can see that's actually just appeared on top of the graph that we already have, because in this case, n is equal to 0. So you can see n equals 0. And what you can then do is use this slider to add or subtract n values. So let's decide that n is 1. So if n is 1, then the graph has gone from 0 as a minimum to 0, 1 as minimum. So it's shifted up by 1. Now if I play with this slider, you can see how it shifts. Now I've told it to only go up by units, half units, but actually, if we're being really strictly mathematical, it's continuous. So it really should be like this. You can see it, there shouldn't be any gaps. It just goes up and down depending on what you've added. So the n, that number n is actually represented by whatever you put in here. So I'm going to change that back to 0.5 for you guys. And then you can see, you can also change the equation of the graph. We'll get to that in a second. So another thing you can do is, I've got a second function, f of x plus t, and this time I'm going to change the t values. So let's see what happens when I change t to a half. Well, if we look closely, that 0, 0 minimum has shifted to negative 0.5, even though I've added 0.5 inside the bracket. So if I change that to 1, you can see it's shifted. It shifted 1 unit to the left. If I change it to negative 1, you can see it's going to go to the right. And you can play around with the scales here. So if you shift these around and you play around with them, you can see what happens when you translate a graph. Now that's fine for a nice and easy graph like x squared, but you might have a slightly trickier graph like x cubed plus 2x. So here's the graph here. So if you want to show the graph, you can just click on the sides here. You can even change the color. If you hold down the mouse button, you can change the color of the graph. Oh, look at that. All of these wonderful colors. You can even have a little dotted graph or a stripy graph. I'm just going to stick to these. Okay, so I'm going to keep that red. Now, g of x, now I've used a different letter. Originally is f of x for x squared. I've decided that g of x is going to be just the next graph here. Now, g of x plus p, now I can see if I add or subtract p, what's going to happen? Well, it's going to go up and down. So I'm going to put that graph on the display, and then you can see if I add p units or if I subtract p units, it changes around. And then I'm going to do the same thing here. On this graph, you can see at the bottom is g of x plus q, except the plus q is inside the bracket. So then you can see that's going to be moving left and right. So I just need to switch that one on, and you can see there's the graph shifting left and right. Okay, so you can have a play around with that, and you can also just come up with your own equations. You can decide to change f of x into anything you want. So maybe even a cubic plus 4x plus 7, and then just hide those graphs and show that one. So that's the graph I've just typed in. You can zoom out, and that's your graph. And then you can play around, because these are already ready to show you that you can play around with them. You can see how the graph changes as it shifts around. So have a go with that. Now back to the lesson. Okay, now that you know what these transformations do, you need to copy this into your book. So any changes inside of x, inside of the brackets, affect the x values, the x-axis, and it moves left or right. And you obviously have noticed that it goes in the opposite direction to the direction you think it goes. So f of brackets x plus 2 means the graph moves 2 units to the left, not to the right. So it's the opposite. And anything outside of the bracket affects the y value. So you can see it's just going to be what you expect. So copy this into your book. This will also be on the worksheet, so you can just print that off. If you have a printer, you can print it, or you can. It's better to copy it out though. So once you've copied it out, I'm going to go through the questions here. So describe the transformation from y equals fx to y equals fx plus 2. So we are inside the brackets. It's going to affect the x values, which means it's going the x values, which are the horizontal values, you do the opposite. So plus 2, the common sense answer would be it goes right, but it does the opposite. So it goes 2 units to the left. And we can show this by using vector notation, which I showed you in the first video. So -2, or you can just say it moves 2 units to the left. But in an exam, if it says use vector notation, then you need to know how to do that. The next question, f of x plus 3, so it's outside of the brackets. Essentially, I'm adding 3 to y. If you think of that as that is just y, f of x is y, so y plus 3. So it moves up by 3 units. So you can say it's going to be 0, 3. The next one is inside the bracket -1. So you do the opposite. So it's going to be 1 unit to the right. So it's going to be 1, 0. And you add 1 to the x values. And then the last one, you can also figure that out. It's going to move down by 5 units. So -5, 0. If you want just a further thing just for your notes, you can copy this slide out. However, this has already been summarized. So if you already know this, you don't need to copy it out. But it's just a summary that I didn't want to delete because it just took me a while to make it. So you can have that. And we're going to look at a couple of exam questions, simple 1-mark exam questions. So let's try this one together. Diagram shows f of x. So it hasn't given you the equation. You can see it's a quadratic, but you don't have any specifics. The coordinates of the minimum point are -2, -1. That's given to you as well. Y is equal to f of x minus 5 in brackets. So I can see it's inside the bracket. So it's going to affect the x value, and you do the opposite. You add 5. So those coordinates there, I'm going to add 5 to my x value, which is -2. So -2 plus 5 gives me 3. The y values stay the same. I think I said -3, should be +3. So it's +3 and the y values is unaffected. Okay, another example here. So you can see that you're given a sketch with all the information. P is 3, -4. Write down the coordinates of the minimum point of the curve with the equation f of brackets x minus 2. Well, f of x is given here. Now x minus 2, that -2 is inside the bracket, so it changes the x value in the opposite way. So you add 2. So 3 plus 2 is 5. And the y value stays -4. And then just pause for a second and have a go at part B. Okay, so for part B, you can see we're adding 6 to the y value. So that original y value, that -4, goes up by 6 to 2. And your x value, you subtract 5, so it becomes -2, 2. And then you might sketch it on the graph if it asks you to. In this case, it doesn't ask you to do it. Now, the last thing I want to show you is reflections. Technically, it's not new information considering you've done the last 2 parts. It's just a small addition to graphs here. So let's fill out the tables here. So x squared is already given to you. So I'll plot those out on there. Okay, so there is your graph of of x equals x squared. And we're going to now do f of negative x. So that means f of x equals x squared. So f of negative x means I replace the x with negative x. So negative x squared, which is just x squared. So you can see the values I'm going to get here is just going to be negative x squared. So negative 4 becomes positive 4. When I square it, I get 16, 9, 4, 1, 0, 1, 4, 9. When I plot those points, I'm basically going to get the same graph here. So it's just going to be just going over this black line. So I'm not going to plot every point here. You can see I'm just going to draw over it. So nothing actually happens here with that negative x inside the bracket. Let's see what happens when you have a negative on the outside of the bracket. So this time around, I'm going to make a point of writing a 1 on the outside just to make it very clear what's happening. So in the same way that when you have negative x, technically you should be writing negative 1x. When you have negative f of x, what you actually have is negative 1 times f of x. And you need to remember that because that's practically never given to you. You just need to know that. So negative 1 f of x just means negative 1 multiplied by f of x. So in other words, all of your y values are multiplied by negative 1. So negative 1 times f of x. Now your f of x values is just x squared. So you can ignore the signs because this happens to be a convenient equation function where it's just squaring. It's always going to be positive. So 16 times negative 1, negative 16. 9 times negative 1 is negative 9. Negative 4, negative 1, 0, negative 1, negative 4. And that's negative 9. So when I plot that, you can see I still have my origin in the same way. 1 goes to negative 1, 2 goes to negative 4, and then you can figure out from here, the graph you end up with is going to be reflected around this point here. So 3 squared, negative 9 is going to be there. So it's going to be like that. So the negative on the outside seems to reflect the graph about the x-axis. So it looks like f of negative x, when there's a negative x inside, did not transform the function in any way. So let's try another function to see if that's true. So this time I've got a cubic. So the cubic graphs, remember, they look like this or they look like this. So let's fill out this table together. So we want to figure out x cubed plus 1. So negative 2 times negative 2 times negative 2 is negative 8, plus 1 is negative 7. Negative 1 cubed is negative 1 plus 1 is 0. 0 cubed plus 1 is 1. 1 cubed plus 1 is 2. 2 cubed is 8 plus 1 is 9. So we plot those points. I'm going to start with 0, 1. Plot this carefully. So 0, 1 is there. 1, it goes to 2. 2 goes to 8. Sorry, it goes to 9 because we're adding 1. Negative 1 goes to 0, and negative 2 goes to negative 7. So you can see there's your curve. It's going to look like this. And we're now going to do f of negative x. So this means if f of x equals x cubed plus 1, then f of negative x is equal to negative x cubed plus 1. Now negative x cubed we are going to need to work out for each value. So let's start with some of the easy numbers here. We'll start with, so negative x cubed plus 1. Start with 0. So 0 cubed is 0 plus 1 is 1. Negative 1 cubed will be negative 1 plus 1 is 2. Negative 2 cubed is negative 8 plus 1 is negative 7. Negative 3 cubed is going to be negative 27 plus 1 is negative 26. And then go to the negative numbers. So if you're putting x as a negative 1, you're multiplying it by negative 1, so it becomes positive 1. And then 1 cubed plus 1 is 2. So we're going to put the negative 2 value in here. So the first thing you're going to do when you put it in there is negative 2 times negative 1, because that's just a negative 1 in there. That makes it positive. So that becomes 2 cubed plus 1, which is 9. Then that 3, when you put a negative 3 in there, it becomes positive 3. 3 cubed is 27, plus 1 is 28. And we're not going to be able to fit that on the graph here, so I'm not going to do that one. Now let's plot this and see what happens here. So negative 1 goes to 2. Negative 3, negative 2 goes to 9, so that's going to be up here. 0 goes to 1, so those points meet. 1 goes to 2. So that point looks like it's a mistake here, actually. So that 2, it looks wrong because that's going up. That doesn't make sense. So I think it should be, well, let's just check that again. So when you put 1 in there, 1 times negative 1 is negative 1. When you cube it, it stays as negative 1. So negative 1 plus 1 is 0. That should be 0. So 1 goes to 0. And 2 goes to negative 7. And you can actually see the shape forming here. 3 is not going to fit on this graph. It's going to look like this. So you can actually see it's been reflected as if this line here was a mirror. So that point there has been reflected across to that side. This point here has been reflected across to that side, and you can see they've all been reflected. So there's a reflection about the y-axis, and now you can probably figure out just by deduction that a negative sign outside of the f is going to multiply the y values of a graph by negative 1. So let's just write this out so we know clearly where it comes from. So f of x equals x cubed plus 1. So negative f of x, remember that's the same as negative 1 times whatever f of x is, so x cubed plus 1. So whatever value you have here, which is the same as the original table, you just change the signs to negative signs. So these y values become negative if they're positive, or vice versa. So we can just write this as negative 1 times x cubed plus 1. Again, you can expand that and simplify if you want to, but there's no real need to. So in this case, we'll plot some points here. So x cubed plus 1. So let's try 0 first because it's just nice and easy. So 0 cubed plus 1 is 1. 1 times negative 1 is negative 1. If x is 1, then it's going to be 1 cubed plus 1 is 2. 2 times negative 1 is negative 2. If we're going to put 2 in there, so it's 2 cubed is 8, plus 1 is 9, times negative 1 is going to be negative 9. And then let's try the negative numbers. So -1 cubed is -1, +1 is 0, that's just going to stay as 0. -2 cubed is -8, +1 is -7, times -1, it becomes +7. Let's just plot these out. These should be enough to make the point. So 0 goes to -1, that's down there. 1 goes to 2. Sorry, 1 goes to -2. 2 goes to -9. And then we can see -1 goes to 0. And -2 goes to 7, which is up there. So this is our graph here. Now, it's slightly harder to see this, but this is actually a reflection along this line here. So if you look at the black line, the original black line, every point there has been reflected. In this case, this case is reflected up, and in this case is reflected down. So there has been a reflection across the x-axis for the green line and the y-axis for the red line. This is also on the Desmos thing. So when you click on that at the bottom, I put some reflections for you. But you can actually summarize what the reflection is. So the original reflection we did with quadratics, actually, the original quadratic just reflected onto itself through the mirror line, just like that. And then when you're reflecting, when the negative sign is outside the bracket, you're reflecting on the x-axis like this. So this is what you need to copy into your books. So copy in books. When you have a graph f of x, if the negative sign is on the outside, you reflect around the x-axis. If the negative sign is on the inside of the bracket, you reflect about the y-axis. Okay, so make a note of that. And then you're going to complete a video, and I might do a little mini whiteboard video for you as well. So see you next time.